guys, this will serve as part 2 of the video on fault indicators, a continuation here with a little bit more in-depth explanation of how they work and something to look out for when you're out there using fault indicators. So on the screen I have here two transformers. You'll see the inbound cable on A, the circle designates a fault indicator, and the outbound cable on B. Then you'll see T2, the inbound primary cable on A, and the outbound primary cable on B. And of course I can have transformers continue on as far as fault indicators and how many ever I need in the line. Okay, if you'll notice in the picture right here, the drawing that I have up, excuse me while I get over here, that the fault indicator really is sensing everything. So if I have inbound cable here and it goes into A, and remember it feeds through the transformer and goes out B, then the A indicator is also monitoring the transformer. Same with this one. So if I have a fuse blown here, draw this in. If I have a fuse blown, designates open, not only is the cable being monitored going into the transformer, but also the transformer itself. So let me get down here and I'll show you. So what we'll have here is a red indicator. Since how we're just using two transformers, we'll go white. So somewhere in this span, like I had described in the video before, we have a fault. Now, that's going to include in the transformer itself, out, and in. Now remember, if this one is white and we have the indicator on the cable right here, everything beyond is okay. So that includes this transformer. That transformer is okay. Everything beyond is okay because we have our indicator on the inbound cable. That's where it's going to stop monitoring right there. So what would happen in a case where the transformer is bad and I have a red and white indicator? Now this is rare. Typically it's going to be the cable itself that's gone bad, or something's dug into it, or some kind of situations like that, or the cable is just old and faulted out. But here's what's going to happen. You're going to come in here and you're going to see red and white and think to yourself, it is somewhere in this span. Keep in your heads, it might be the transformer. Maybe. And here's how you're going to find out. Now, we don't have a testing tool with us right now to test a transformer. They do make them out there in the world. But our assumption is, because cable is the most likely problem we have in this situation, we're just going to isolate the cable. So what we're going to do here, in this situation, if this is our suspect span, we're going to come up here and we're going to park the outbound B. It comes off of B, and we're going to park it right here in a parking stand. And we've already discussed this before, what a parking stand is. So we're still feeding into the transformer. Now I won't get into isolation. We'll talk about isolation a little bit on. Remember, we're still talking about fault indicators. Well, if this is parked, I can go ahead and close this fuse now, because in my mind I have isolated the span, and that's our suspect span cable. We close the fuse, and all of a sudden the fuse blows. And you're thinking to yourself, well, I've isolated the span in between, but I still have that phase on the transformer. So a good test right here would be to go ahead and remove A from the transformer and high pot. at your dip. If your cable high pot's okay, you've got a bad transformer. All right, a little bit of extra work going on, and like we said, transformers are very reliable, especially pad mount transformers, because they're not getting struck by lightning as much. But that is the scenario that you may run into. Okay, in summary, we're typically going to go out and have a red and a white and suspect the cable. All right, we're going to have to go ahead and stand off the B wire because we think it's in this span, the outbound span between here and here. We're going to have to do that to be able to get this transformer back on. You reclose the new fuse. The fuse blows again. All right, now the transformer is very suspect. You may have a fault in A, but that's really what in the A cable. But we suspect that the transformer is bad. High pot. Across here to your cable, you're going to have to remove this off. So remember, you have to isolate this. You have to take this off and park it also. High pot. That span shows good in your high pot sticks. The transformer is no good. All right. Just want to give you that added information right there that, you know, fault indicators are not only indicating or showing a fault on the cable, the transformer is in the mix here too. The windings of the transformer itself. So if we have a fault indicator at this location, and I'll get kind of full right here, get some of this out, get this back to normal. The fault indicator, primary feeds in A. The fault indicator from this point and beyond is seen here. The transformer itself, any faults inside that may have occurred, and the cable, all the way up to the next fault indicator where it stops. That's all it's looking at right here. Here to here, inside the transformer, up to here and stops. Now the next one down the line, you've got it mounted on the A phase. What's it doing? It's watching this cable inside the transformer all the way out and then stops, and on and on and on. Okay, that'll be it for this video. Just wanted to give you some information that included not only the cable, but the transformer, maybe the suspect fault condition also. If you run into something like this, usually if the transformer is bad, there's going to be some smoking, charring, maybe a little bit of oil leak coming out of it, but you will see some indication on the transformer. I just wanted to give you the instruction of what the fault indicator does see. All right, gentlemen, appreciate your hard work. Have a good day, and this will be the end of this video.